In the previous video, we proved that if we have a non-negative, sorry, if we have a positive sequence, then its limit is non-negative. So we have a corollary. If we have two sequences, two convergent sequences with xn greater than yn for all n greater than equal to m, then the limit of xn is less than greater than equal to limit of yn. So let's see its proof and why we have used the term corollary, because we will use this theorem. So let's see, xn is greater than yn. Okay, this implies what? This implies xn minus yn is greater than 0. So let wn to be xn minus yn, then wn is greater than 0. But wn is greater than 0 and xn and yn are convergent sequence. So wn, being the difference of two convergent sequence, is convergent. Okay. So w1 greater than 0 and it is convergent. Convergent means what? That limit of w1 exists. So use the theorem. So using previous theorem, we have limit of w1 to be greater than equal to 0. But limit of w1 is what? Limit of w1 is limit of u1 minus vn. Sorry. xn minus yn greater than equal to 0. Use algebra of limits. Limit of xn minus limit of yn greater than equal to 0, or limit of xn greater than equal to limit of yn. So we use the previous theorem to prove this theorem very easily. We'll next move on to another famous theorem called sandwich theorem. Many say this is a squeeze theorem, but I prefer the term sandwich theorem. Let's write this statement. Let xn, yn, zn, okay, xn, yn, zn be convergent sequence with xn less than equal to yn less than equal to zn. I am taking less than equal to. You can also take less than. Okay, so less than equal to, and limit of xn equals to limit of zn. Then limit of yn is also equal to limit of xn equals to limit of zn. A very easy proof. We will use the above theorem or already proved theorem. So let's see the proof. So we have what? Xn is less than equal to yn. This implies what? This implies limit of xn is less than equal to limit of yn, right? And we also have yn is less than zn. So limit of yn is less than equal to limit of zn. But given what? Given limit of xn is equal to limit of zn. So this translates to limit of zn less than equal to limit of yn. Okay, now give this number 2, this number 1, combining 1 and 2, we get limit zn less than equal to limit yn less than equal to limit zn. But these are equal, so limit of yn is limit of zn. But again, limit of zn equals to limit of xn. So this proves the theorem, and this theorem is very important for our examples, and we will use this theorem to generate the limit of many of our sequence of many important sequences. So remember this theorem. Okay, thank you.